Hey guys, welcome back to this course. In the previous video, we had taken a look at the concept of number sliders and panels. And at the end of the video, as I had mentioned, we would actually understand the concept of data trees. But in order to understand the concept of data trees, you would actually have to first go through these many panels over here. Now please don't get confused because I have a lot of panels over here on the top. Most of them are plugins, but in your case, you will mostly have your panels up to over here, which is display. You'll have from parameters till display. Now in this case, we'll actually take a look at some of the very important components inside each of these tabs. So you have parameters, you have math, you have sets, vector, curve, surface, mesh, intersection, transform, and display. Now some of these tabs are important, some are not, and most of these tabs have very essential components that you should understand before going into the concept of data trees. So we will be beginning with the math tab, since we have already taken a look at some of the components inside the parameters tab like point and panels and the number sliders. So let's directly jump into the math tab. So I'll just minimize my Grasshopper window over here like this. I hope all of you have your Rhino window on the left hand side and your Grasshopper window on the right hand side. Now you guys can see that I have a script opened up over here. It has these small scripts with their titles written on the top. This particular script you can actually find inside your exercise file that you will download. The name of this script is the math tab. So I'm inside the math tab right now, and this script actually has some of the very essential components that we'll be understanding. So you guys can actually go through this script as I explain each and every component and how it works and what it is all about. So I'll be starting with the construct domain component over here. Now before I begin, you must also understand that each of these components can be bought in from the math tab over here, and as you can see, the math tab contains 9 panels and 109 components that is inside Rhino 6 and Grasshopper, the new Grasshopper that you have inside Rhino 6. The math tab has 9 panels and 109 components. We don't need to understand the total 109 components. We'll only need to understand a few important ones which I have listed right here. So let's get into the first one. Each of these components you can actually bring in from the math tab. If you are confused that where does this particular component belong to, you can just hold your right alt and click on any component that you want to. For example, I'll just hold my right alt and I'll click on this particular component which says construct domain. As you can see, Grasshopper actually tells me where this component is located. It's located in the math tab, and the first component that you can see, which is signified by the red arrows and the red circle, which is the construct domain component. It doesn't matter if you are in some other tab, you can just use your right alt key and press on that particular component, click on that particular component with your left mouse button, and it will actually show you where the component belongs. So let's begin with this particular component. You can also double click and type the name of the component if you want to. So in this case, if I type construct domain, you see I have the construct domain component. I can just click and bring it in, and you will have the same component. Make sure you notice the icon and the text, which is the input and the outputs, and you'll be good to go. So I'll just delete this particular component. Now the construct domain, as you can see that I have written on the top, these are basically scribbles. You can just double click and type scribble and bring in the scribble component, and you can basically double click and make a note. You can change the text type, the text size, and you can just keep it on top of your script. So I'll delete this for now, and these things that you can see around the small script. So whatever script you create, for example, if I delete this for now, so say you created this particular script. Now all you need to do is select it whole and use your central mouse click and click on group, which is basically create a group containing all selected objects. So click on this and it will be grouped. If you want to change the color of this, select it, it will turn to green. Do a right click, go to color, and you can change the color from over here. Now let's understand this particular component. So this is known as construct domain, which tells us that it creates a numeric domain from two numeric extremes. So over here I have attached two number sliders the domain start and the domain end. So the domain start is basically 0.165, as you can see, which is a number slider from 0 to 1, and the domain end is 0.948, which is a number slider from 0 to 1 again. And I can basically control the extremes, which means say I pick two random numbers over here like 0.1 and 0.917. So there can be infinite number of numbers between 0.1 and 0.917. What construct domain does is it gives me that infinite range and tells me using a panel that okay, now I have a domain of numbers ranging from 0.1 to 0.917. So you can basically construct a domain of numbers using this particular component. Now let's go to the next one, which is bounds. Now in order to understand the bounds component, you can just see where this particular component is located. You can click on it, use your right alt key, and you can actually find out where it is located. It is located right there under the math tab. And now I have also attached a series component to it. We'll come to the series component. For now, you just need to understand that the series component is located right here inside the sets tab. We'll go back to math, and it has three inputs: start, step, and count. I've basically attached random number sliders to it, and just make sure that the count is a non-decimal number slider. And the output I've actually attached to the numbers input of the bounds component. Now what the bounds component will do is it creates a numeric domain which encompasses a list of numbers, which means that the bounds component will give me the starting point and the ending point of a domain. So say if I have a domain of numbers over here, I have a series of numbers over here from 0.514 to 59.626. So I am getting the starting point, which is 0.514, as you can see, and the ending point, which is 59.626, as you can see over here. So it will give me the minimum and the maximum of that particular domain, which is the bounds component. Now let's go to the next component, which is remap. In order to understand remap, I've again used the series component that I've used over here, and I've used the bounds component that I've used over here, and I've also used the construct domain component that I just explained over here. I've used all of these three things, and I've used the remap numbers. So remapping a group of numbers is basically using the logic of fitting a set of numbers into another set of numbers, which means that say this particular series component gives me these particular numbers, and I can actually extract the bounds. I can create a new domain, like a new range of numbers, and I can fit all these three things into value, source, and target. So the series is actually the list of numbers which I want to remap. Source is actually the domain of numbers under which I want to remap these numbers, and this particular component, which is the target, it gives me the domain of numbers under which I'll actually remap all these numbers. So when you fix in all of these three inputs, it will give you the mapped numbers. So over here I am mapping these numbers to a list of 0.139 to 0.846. So all these numbers will be mapped under these numbers. So now you see these numbers starting from 0.847, 1.694, and all of these numbers now are remapped under 0.139 to 0.846. So as you can see in the output over here, starts with 0.139 and it ends at 0.846. So you basically remap a set of numbers from one list to another list using the remap component. Now let's see the divide domain square component. So this particular component you can find right over here, as you can see under the math tab. Now this component contains three inputs. You have a surface input, which means you have to input a surface. I'll just turn this on. Anything that you want to turn on, you can just click on that particular component, use your central click and click on enable preview. If you want to hide that component, you can select it first, it will turn green. You can use your central click and click on disable preview like this. So I'll just turn it back on. You have this particular surface that I have created in Grasshopper. So it's inside this particular surface component, and I have attached it to divide domain square. So what particular component does is it divides up geometry into a particular number of u and v counts. U and v is nothing but x and y counts. So it's known as u and v in the Grasshopper syntax. But over here, after you get your segments, so this particular component does not give me any output. You see, I can't turn this on. it's still in a dark gray color. So over here I have the isotrim component. If I turn this on, you'll see the change that has actually happened on this surface component. I'll turn this off, otherwise it'll just overlap this output. So as you can see, I have the isotrim component that I have attached to this particular component, which is divide domain square. I've attached the surface as the surface and the domain as the domain, and I get this particular output, and it's a completely parametric script, which means I can change the u count and I can change the v count like this. So if you want to know where the isotrim component came from, you can just use your alt key and your mouse click and you will come to know where it came from. So it's under surface, under utilities over there. So this component I'll be explaining under the surface tab in explicit detail, but for now just understand that the divide domain square can be used in order to divide up a surface into particular subsets under the u and the v count, which is basically the x and the y counts. So I'll just turn this off. Let's go to the next component, which is addition. So addition is basically your basic addition. You can just input two numbers and add it up and get a result. So I've used a panel to show the result, since I cannot see numeric results in Grasshopper in the Rhino window. So it's not a geometric result, it's a numeric result. So I've used a panel over here. So you have two inputs, A and B, and you get a addition result. So basically if I change this, it changes accordingly. The same case is with subtraction. You can just create a parametric subtraction script, a small script, which means you have two inputs and one output, and you can basically subtract this value from this value and you can get a result. So in the same way, you also have multiplication and you have division. So you have addition to division. All of these small scripts basically work the same way. Now let's move on to average. So this particular component, you can just click and use the alt key again to understand where it is located. It's under the math tab, under utilities, as you can see on the screen. And now you can also see that you have these four number sliders. Now I have actually created these four number sliders, random sliders, and I've inputted them inside one input. Now if you are confused as to how to input four sliders into one, I'll just show you over here. I can just double click and type average and bring in the average component. I can do this and bring it in, or I can just go to math tab. Under utilities, you will find average over here. Click and bring it in. So whichever way you find easier, I can just delete this for now. Now if, say I want to attach all these four number sliders into one, so you'll have to hold shift and you see a small plus sign that appears in under my cursor. You can just click and bring all your number sliders in like this. Make sure to hold shift and you can attach multiple sliders inside one input. So I'll just delete this for now. After doing that, you see I have the arithmetic mean of all these numbers. So if I change it to say 100, and see I just double click and change it to 80, I just double click and change it to 70, and I can double click and change it to 60. So now I have an arithmetic mean between 60, 70, 80 and 100, which is 77.5, which is exactly accurate because I'll have the mean somewhere over here between these four numbers. Now let's go to the round component. The round component can be found just over here. You can use the alt key and your mouse key to find out where the round component is. It's right there under utilities. So you just have to enter a number. You can enter it through a panel, you can enter it through a number slider, depends on what you want. And you basically get three numbers. If it's a decimal number, which in this case is 33.173, I'm getting three outputs: nearest, floor and ceiling. So the nearest gives me the integer nearest to the number that I have inputted, which is 33. Floor gives me the first integer smaller or equal to this particular number, and the ceiling gives me the first integer larger than or equal to this particular number. So in this case 33.173 can be rounded off to 33, or if you hit the ceiling you can round it off to 34 in this case. So I guess that's all the components that you should know and you should explore under the math tab. I've pretty much covered all of these things over here. You can just take a look at these scripts. You can explore what this script has to offer. In the next topic, let's take a look at the sets tab. where you have these particular components. Under these particular topics, you have list, sequence, sets, text, and tree. So let's take a look at the sets tab in the next video.